Team is Mr. Z, and today we're going to determine whether graphs have vertical asymptotes while simplifying. Let's dive on in, shall we? So looking at this guy, the important part is to identify where the domain cannot be 0. So x plus 3, when is this denominator going to be 0? The question you ask yourself is, when does x plus 3 equal to 0? And through quick solving, you can identify that x cannot be negative 3. Now, you can write out the domain. The domain would be as follows. If you want to look at it on a number line, the domain is going to go from negative infinity to positive infinity, and it's going to be broken up at the asymptote negative 3, thus making the domain negative infinity to negative 3, union negative 3 to infinity. The graph is broken up into 2 parts. Okay, now comes the fun. We need to simplify this function. And essentially what you're going to do is you're going to look for opportunities where you see x plus 3 on both sides. Now, I want you to understand that this denominator, there is a grouping symbol around this x plus 3. And what I see is x plus 3 divided by x plus 3 is going to result in 1. So really, this turns into x times 1 over 1. Well, what is that just? It just means f of x is going to be equal to x. However, it does have this caveat where x cannot be negative 3. Even when it's simplified, the domain restriction doesn't go away. That's why you have to identify it first. Let's go ahead and look at our next one. So g of x equals x squared minus 3x, x squared minus 9. Basically, you should have an autopilot where you want to factor this. And I'm going to factor out a common x for my first term, leaving me with x minus 3. I get x minus 3 times x plus 3. Okay, time to identify when math breaks and the denominator is 0. I ask myself, when is x minus 3 equal to 0? I ask myself when x plus 3 equals 0. And I can identify that x at these two values, it cannot be. So in order to write my domain, I go from negative infinity to positive infinity. And it cannot be negative 3. It cannot be 3. So to write out my domain, it is going to be negative infinity going to negative 3. Then the next region it's talking about is from negative 3 to 3. And then finally it goes 3 to infinity. Notice how I have 3 parentheses. I have 3 regions. Okay. All right, let's go ahead and simplify this guy. You should see that in the numerator and the denominator, they share an x minus 3. Those are going to cancel out, leaving you with g of x is going to be equal to x over x plus 3, where x cannot be 3 and negative 3. Notice how even in the simplified version, I have my domain restriction. It's why we look at it first. This next guy, notice how it's in factored form right away. So I look at where my denominator is going to break. aka when my denominator is going to be equal to 0. And by sight, you should identify x cannot be 3 and x cannot be 4. Now, drawing out my number line, in order to help identify my domain, I go from negative infinity to positive infinity and 3 to 4. This enables me to say that the domain is going to be from negative infinity, it goes to 3, union 3 to 4, union 4 to infinity. Notice how the number is always repeated. It's because we're describing the region between negative infinity and 3. Then we're describing the region between 3 and 4. And then we're describing the region between 4 and infinity. These are the 3 regions that are created by my asymptotes. Now, let's go ahead and simplify this. My numerator, boom, boom. Now, some of you might be saying, well, h of x is going to be equal to nothing over x minus 3. However, it's important to remember that it is not just nothing. It is actually a 1 that's created. A number divided by a number is 1. 2 divided by 2 is 1. X divided by x is 1. X minus 4 divided by x minus 4 is 1. So what really happens is it transforms into this guy, which we can quickly simplify to be like so. But I have to remember where x cannot be equal to 3 or 4. All right, let's jump into the last guy. Oh my God, what am I going to do? Well, factor. Now you're going to have to use an advanced factoring technique. Good thing our last unit was about factoring. Now I want you to know that my domain still x cannot be 1. So my domain is going to be negative infinity to 1, union 1 to infinity. Now there is a clue that's given to you. I'm telling you to simplify. So my theory is there is going to be an x minus 1 is going to be a factor. So I'm going to actually divide the numerator by x minus 1. I can use long division or synthetic division. I'm going to do both here. X minus 1 divided by x to the third minus x squared plus x minus 1. I ask myself, x times what makes the first term x to the third? And that's going to be, well, I need 2 more x's. X times x squared is x to the third, and I have to distribute it into both. So this is going to be minus x squared. And then since it's long division, I subtract. I'm going to go ahead and end up getting, well, 0, a sign that I'm doing it right, and 0. Rock on. Bring down my next number. It is a positive x. And I have to ask myself, hey, x times what is going to be x? Oh, well, that's just 1. So I'm going to multiply by 1. I distribute it to both parts. 1 times x is x. 1 times negative 1 is negative 1. Since it's long division, I subtract. And I'm going to be left with, after I distribute, it's going to be 0 and a positive 1. I bring down my minus 1, and you can see how that makes 0. So essentially what we discovered is x minus 1 times x squared plus 1 is the same thing as the numerator. Let's go ahead and show you the same process with your second option. I can use synthetic division. So when I'm doing synthetic division, I think about what's the factor that is going to make 1. I look at the coefficients of my number I'm dividing, 1, negative 1, 1, negative 1. And to get started, I bring the first number down. 1 times 1 is 1. Then I add them together, makes 0. 1 times 0 is 0. 1 times 0 is 1. 1, 0. This last one is going to be my remainder. So essentially what it's going to look like is I go right to left. It is going to be 1 plus 0x plus 1x squared, aka the same thing that we discovered before, that x minus 1 times x squared plus 1 is equal to the numerator. All right, all of this fancy stuff we've done, but essentially what it enables us to do, the reason we learned this division is to be able to factor the top to say x minus 1 over x squared plus 1 over x minus 1. Cancel, cancel. I do want to point out that technically what is happening, the inner workings means that it's going to be x squared plus 1 over 1, but any number divided by 1 stays the same. So j of x is equal to x squared plus 1, where x cannot be 1. This problem highlights the importance of knowing synthetic division or long division as a necessity to factor and therefore simplify. That's it for now. Ciao.